In the previous lecture, we have studied microphones which convert sound energy into electrical energy. Now let us study the opposite process. Once the electric signal is generated and amplified, it must be converted back into sound so that we can hear it. This is the function of a loudspeaker. So a loudspeaker is an output transducer that converts electrical energy into sound energy. It is one of the most important components of any entertainment system. Whether we use a television, home theater, Bluetooth speaker, mobile phone, laptop or public address system, a loudspeaker is responsible for producing the final sound that reaches our ears. The quality of loudspeaker determines how clearly we hear music, speech and other audio signals. Therefore, understanding its construction and working principle is very important for electronics engineers. Let us first study the construction of a loudspeaker. Although loudspeakers are available in different shapes and sizes, the basic construction remains almost the same. At the center of the loudspeaker, a permanent magnet which creates a strong and constant magnetic field. This magnetic field is essential for converting electrical signals into mechanical motion. Placed inside this magnetic field is a voice coil which is made of several tons of insulated copper wire wound on a lightweight cylindrical former. The voice coil is free to move inside the magnetic field without touching the magnet. The voice coil is attached to the speaker cone, also called the diaphragm. The cone is usually made of lightweight materials such as wrapper, plastic or composite fiber. Its main function is to push and pull the surrounding air to produce sound and waves. The cone is supported by two important mechanical parts. The first is surround, which one is flexible outer edge connecting the cone to the speaker frame. It allows the cone to move freely while keeping it properly aligned. The second is the spider located near the voice coil. The spider keeps the voice coil exactly at the center of the magnetic field and prevents unwanted sideways movement during operation. The entire assembly is mounted on a rigid metal frame which provides mechanical support and protects the internal components. We have seen this. Now let's understand the working principle of the loudspeaker. The loudspeaker operates on the principle of electromagnetic force, which is based on the Fleming's left-hand rule. When an electrical audio signal from an amplifier flows through the voice coil, the coil behaves like a electromagnet. Since it is placed inside the magnetic field of permanent magnet, an interaction takes place between the two magnetic fields. This interaction produces the force on the voice coil. As the direction of electrical signal continuously changes, the direction of force also changes. Consequently, the voice coil moves rapidly forward and backward. Since the speaker cone is attached to the voice coil, it also moves in the same manner. This continuous forward and backward motion of the cone compresses and rarefies the surrounding air, produces sound waves. If the electrical signal has a low frequency, the cone vibrates slowly and produces low-pitched sounds. If the electrical signal has a high frequency, the cone vibrates rapidly and produces high-pitched sounds. Similarly, if the electrical signal has a large amplitude, the cone moves a greater distance, producing louder sound. Thus, the loudspeaker faithfully reproduces the original audio signal in the form of an audible sound. Now, let us discuss the different types of loudspeaker. The first is dynamic loudspeaker, also known as the moving coil loudspeaker. This is the most widely used loudspeaker in the world. Almost all televisions, Bluetooth speakers, public address systems, home theaters and multimedia speakers use dynamic loudspeakers because of its simple construction, high efficiency and excellent sound quality. Its working principle is exactly the same as the one we have just discussed. The moving voice coil interacts with the permanent magnetic field to produce sound. The next is permanent magnet dynamic loudspeaker. In early loudspeakers, the electromagnets are used to create the magnetic field. However, modern loudspeakers use powerful magnets made from the ferrite or neodymium. Using permanent magnets offers several advantages. They eliminate the need for an electrical external supply to produce the magnetic field, reduce power consumption, simplify construction and improve overall efficiency. Because of these advantages, permanent magnet loudspeakers are now used in almost every modern audio device. Now let us study two special loudspeakers designed for different frequency ranges. First is woofer. A woofer is specially designed to produce low frequency sounds, typically ranging from about 20 to 20 kilohertz. 20 Hz to 20 kHz. These low frequency sounds include bass guitar, drums, thunder, explosion in movies, and deep musical notes. To move a large amount of air, a woofer uses a large cone and a relatively heavy voice coil. This allows it to produce powerful bass with powerful high efficiency. The second is tweeter. Unlike the woofer, the tweeter is designed to produce and reproduce high frequency sounds, generally about 2 kHz. These include human speech, violin, flute, cymbals, birds chirping, and other soft sounds. Since high frequency sounds require only small air movement, tweeters use a small and lightweight diaphragm, enabling them to vibrate extremely quietly and reproduce fine sound details accurately. So these are the different types of tweeters. So next is crystal speaker. A crystal speaker operates on the inverse piezoelectric effect. Earlier, while studying crystal microphones, we learned that applying mechanical pressure to a piezoelectric crystal produces an electrical voltage. In a crystal speaker, the reverse process takes place. When an alternating electrical signal is applied to the piezoelectric crystal, the crystal expands and contracts continuously. These small mechanical movements are transferred to diaphragm attached to the crystal. As the diaphragm vibrates, it creates sound waves that travel through the air. Crystal speakers are more compact, lightweight, and consume very little power. They are mainly used in electronic buzzers, alarm systems, electronic toys, watches, small portable devices where only a low sound output is required. However, crystal speakers cannot produce powerful bass or high sound levels, therefore they are not suitable for musical systems or home theater applications. Next is this is structure of crystal loudspeaker. Next is electrostatic speaker. Unlike conventional loudspeaker, they use magnets and voice coils. Electrostatic speakers work using electrostatic attraction and repulsion. They consist of a very thin, lightweight diaphragm placed between two perforated metal plates called stators. A high voltage is applied to the diaphragm while the audio signal is applied to the stator plates. As the electrical voltage signal changes, attractive and repulsive electrostatic forces are produced, causing the diaphragm to move rapidly. Because the diaphragm is extremely light, it can reproduce sound with exceptional accuracy and very low distortion. The electrostatic speakers provide outstanding sound quality, making them ideal for high-end music systems and professional audio applications. However, they are expensive, require special high voltage power supply, and are more delicate than conventional loudspeakers. As a result, they are mainly used by audiophiles and premium sound systems. Next is modern audio systems. One of the modern audio systems is 2.1. The number 2 represents two satellite speakers and 0.1 represents subwoofer. The satellite speakers handle speech, vocals, and most musical instruments, while the subwoofer reproduces deep bass effects such as drums, explosions, and background music. This combination provides a rich and balanced listening experience. Because of its compact size and affordable cost, the 2.1 audio system is widely used with desktop computers, televisions, multimedia systems, and Bluetooth speakers. Next is 5.1 home theater system. A 5.1 system consists of 5 speakers and 1 subwoofer. The front right speakers reproduce music and general sound effects. The center speaker is mainly responsible for dialogues in movies. 2 surround speakers are placed behind or beside the listener to create 3-dimensional surround system. Finally, the subwoofer reproduces powerful low frequency sounds. Imagine watching an action movie. With a 5.1 system, you can hear a helicopter approaching from behind or a car moving from one street to another. A rainfall surrounding you from all directions. This creates a realistic cinematic experience inside your home. So you are seeing this. Now let us move on to display technology. So we have seen different display technologies like cathode ray tube, commonly known as CRT. It uses a electron gun. And next is liquid crystal display, which uses flat panel displays and backlight. The another one is LED display. This is LCD. The another one is LED. And many people think that LED television is completely different from an LCD television. In reality, an LED television is actually an LCD display that uses LED light emitting diodes instead of fluorescent lamps for backlighting. Thank you.